So I talked to IT. They showed me another way to record, and Daryl, the tutor, showed me about it. It was telling me that we can pretty much I can save it onto the cloud of the Zoom, which you guys can see on Canvas. I'm gonna do that way, and I'm also gonna download it and put it on YouTube. But I'm just experimenting with this cloud because I didn't know this was an option. So I wanted to see how that would be. All right. If you still need more time on this slide, guys, go ahead and please screenshot the slide or take a picture with your phone. All right. And remember, this video lecture will be accessible after class, whether it be on the cloud or YouTube, okay? So, all right, so that's an equation. So helpful hint. So before we get into some examples, write this helpful hint. Simply stated, an equation contains an equal sign while an expression does not. Also, we simplify expressions, but we solve equations. So I really enjoyed this helpful hint because it kind of differentiates the difference from expressions to equations. And then I'm going to read example one. Example one says, determine whether -1 is a solution of the equation 3y plus 1 equals 3. So I'm going to go ahead and give you guys a 3-minute timer. Now, for example one, determine whether -1 is. So does anyone know what we're going to do with the -1 to see if it is a solution? Anyone remember?
Do we plug it in?
Yeah, we're going to plug it in for y. We're going to plug it in for y. So we're going to get 3 parentheses -1 plus 1 equals 3 with the question mark on top of the equal sign. Whenever you're plugging in something and you're not entirely sure if it's a solution or it's going to be true, if you're not sure, a question mark has to be on the first line to kind of tell me and you, hey, we're plugging in -1, but we're not too sure if it's an actual solution. And now we use algebra to simplify it. 3 times -1 is -3. Bring down the plus 1 equals 3. -3 plus 1. You owe me $3, but you pay me 1, so now you owe me $2. -2 equals 3. That is false. Since it is false, we can say that -1 is not a solution. I'm gonna go ahead and add 2 minutes for you to do practice 1. Your job for practice 1 is determine whether -2 is a solution of the equation -4x minus 3. You have any questions, feel free to ask now or ask your classmates or type it in the chat if there's any questions so far. Now, when you all plug in a -2 for x, guys, you're gonna plug it in for practice 1, and you're gonna tell me if it's true or false. Tell me what it is if it's false. What do you say if it's true? You have 1 minute left. And on the chat, you're gonna write, excellent. Joshua sent me the solution to myself. Thank you, thank you. You are correct. And it's not that 5 is a solution. Which one is a solution, Josh? What are you testing to see? What do we plug in, class? There we go. So your statement to the class now in the chat should be -2 is a solution or -2 is not a solution, depending if it is or not. So we see Tanya said it is the solution. -2 is the solution. Good, good, good. There you go. Okay, you see the difference, Josh, about -2 and 5? Riley, you guys see the difference? Okay. As long as y'all know the difference of which one we're saying is solution. So remember, at the end of the day, we're saying -2 is or isn't. And we're going to say right here, -2 is a solution. If you got that, go ahead and give yourself a check mark on your notebook and let's move on. Now, if you ever get a practice problem wrong, don't erase it. Just put wrong and then write it correctly so you can see where you made a mistake and what was the correct way to do it. Now, the addition property. I'm gonna go ahead and give you guys 3 minutes to copy the addition property and to write down example 2. So 3 minutes. While you guys are writing the addition property of equality, I'm gonna read it to you. Let A, B, and C represent numbers, then A equals B and A plus C equals B plus C are equivalent equations. Also, A equals B and A minus C equals B minus C are equivalent equations. So the key word here, guys, is equivalent, right? So what does that mean, right? What is this property emphasizing for us? So what this property is telling us, class, is if we add one thing to one side, we also have to add it to the other side. Because if what we do to one, we do to the other. Like example, I want you to think of an equation as a balanced scale, right? Imagine it's balanced. There's 10 pounds on both sides. To keep it balanced, if I add 5 pounds to one side, to keep it balanced, I also need to add what to the other side? 5 pounds, right? So if I add 5 here, add 5, and it still stay balanced, it'll stay equal. But imagine the same 10-pound scenario. We have 10 pounds, 10 pounds on each side. What if I take away 3 pounds on one side? Well, to keep it equal, I'm gonna have to take away 3 pounds from the other side to have the left side always equal the right side. And that is what equations represent. I want you to look at an equation and be like, oh, so the left side equals this right side. And to keep it equal, whatever we do to one side, we have to do to the other. And you're about to see the art in that in 30 seconds once the timer goes off on example 2. So the equation for example 2 says solve x minus 2 equals -1 for x. Whenever you have an equation that we have to solve for, the first thing I want you to do is draw a line down the equal sign. That line represents the balance, the scale, the part that holds both sides, okay? Now look at the equation. The equation says x minus 2 equals -1. So guys, x is gonna be a number. X is going to be a number, but we don't know what number it is. X is it's a variable. It's an unknown variable. We don't know what X is, but we know what we do know. It's a number. So I can ask you, so pretend there equals -1. So X minus 2. So if I was to tell you, hey, find me a number that if I take away 2, it gives me -1. Then at that point, you will guess, right? You'll be like 3. Well, 3 minus 2 is +1. And so it's not 3. And you keep guessing and guessing. And can we figure it out that way eventually? We can, right? But that's not what this class is about. This class isn't me having you do this on your own. This class is me bridging you from, oh, that makes sense. Yeah, we can pretty much guess until we get it, to the, oh, that's how we do it. That's the process. So let me show you something. So our goal is we want to get X by itself. But what's happening to the X? What is this 2 doing? It's subtracting. Now, to manipulate equations, class, watch carefully. We're going to do the opposite or inverse operation to everything around the letters to get the letter by itself. So since we have X minus 2, we're going to go ahead and do the opposite of -2, and we're going to do +2. But remember the property, to keep it equal, what we do to one side, we do to the other. So we're going to add 2 on both sides. But look, -2 plus 2, that cancels out with 0. And we have X by itself. So we're going to bring the X down by itself. Equals, now look at the right side. -1 plus 2. You owe me $1, but you deposited 2. So now you only have $1 to yourself, and box your answer. And we're done. Any questions on the step we just took? So we did the opposite, all right? Pay close attention to that, okay? I'm going to give you about a minute to copy example 3 down. 1 minute. -8 equals n plus 1. Now, I'm going to tell you about a mathematical property that we can utilize before we solve. Guys, if A equals B, that is the same thing as being able to say B equals A. So mathematically, with equations, we can flip them and they still mean the same thing. That's what this property means. This is an equal sign with 2 arrows on the outside. That's what that is. So that means saying we can go back and forth. So if we have -8 equals n plus 1, that's going to be the same thing as n plus 1 equals 8, -8. Now, I personally make that change myself. Maybe because I'm lefty, maybe because I'm a left-handed, maybe because I'm used to it. But I personally like to have the letters by themselves on the left side. So you can manipulate this, okay? So now we have n plus 1 equals -8. What is the opposite of plus 1? Remember, the opposite of plus 1 is -1, right? And what we do to one side, we do to the other. That cancels out. So then we have n equals -8 take away 1. So -8, we owe the bank 8, but we spend another $1, so we get -9. And we're done. N equals -9. Take a look at example 4. Solve x equals -60 plus 4 plus 10. As you write down example 4, class, is x by itself? Is there anything next to the x that we're going to have to move? No, right? There's nothing there. It's solo. He's by himself. So now we're just going to simplify the right side. We simplify the right side because they're all numbers. They're all like terms. We can combine them. -60. So we owe the bank 60, but we gave them $4 and then we gave them another $10. So from here to here, we get -56 plus 10. And then we combine those two and we get x equals -46. And we're done. We just combine like terms. Any questions what we did on example 3 and 4? All right. If there are no questions, class, here are your first set of practice problems. I'm gonna give you guys 4 minutes. Good luck. Oh, 1 second. I'm gonna stop the timer. I had a question sent to me. So the question was, how did I get negative 46? I just combined the like terms. So I combined negative 60 and negative and positive 4. So you owe the bank $60, right? And then you deposited 4. So you still owe them 56. I brought down the plus 10. So we still owe the bank $56, but we gave them how much? I gave them $10 because I'm adding to my bank. But as not enough, I'm still going to owe them $46. So in your calculator that you have or your phone, you to type in negative 60 and do plus 4 plus 10, and you should get negative 46. All right, here is the first set of practice problems. And your 4-minute timer starts now. Now remember, your solutions for equations should be y equals a number, z equals a number, x equals a number. It's supposed to be something equals something. And it can't just be a number. You can't just say 5 is my solution. No, it has to be a statement.
I do have a question.
Yes.
So like on the problems like where you do the opposite to the other side, do you only do that when there's no other numbers besides like only one with the
With the letters, right? That's your question. Like, do we do it only with the numbers next to the letters or every other number? Like, for example, hold on 1 second, okay? I'm just writing a message to the chat. Okay, so your question, Kayla, is look, for example, the first practice problem. Let me label these. So this is 1, this would be A, B, and C. So on A, what are we gonna do the opposite on, Sarah, for A? On the 6 or the 2?
On 6.
right? Because it's next to what?
Next to the
The y, right?
yes.
On B, which one are we gonna move by itself?
Would it be the instead of the positive 8, it's gonna be negative 8, minus 8?
We'll do minus A, right? Because it's the opposite of plus, right? And then what about on the X, on the C? Is there anything we had to move over from the X?
No,
No, so then we just combine what?
I like terms.
There you go.
Thank you.
No, thank you for your questions, guys. All right, anyone need more time to work on these before we move on? So before we move on, for A, what did I get for A? Y equals what? You can type it in the chat or you can tell me on there.
Got 4.
Sylvia, y equals 4. For the ones that wrote y equals 4, thank you. That is correct. If you wrote 4 by yourself, you may not get it right if it was like a paper assignment, okay? But make sure you have the proper notation, okay? Now, what about for B? Anyone want to share what they got for B?
Oh, I got -4
Yeah, Z equals, oh, for Y or for Z?
for Y.
You got -4?
Yeah.
Okay, let's test it out. Let's see what happens. How did you move the 6, Jacob?
I put it +2 on both sides.
+2, you sure? Remember, what's the objective? The objective is to get what by itself, sir?
The Y,
The Y. So what's next to the Y that we should move over?
the 6.
The 6. You
Yeah,
moved
I
to
put a
what?
2. Yeah, 2.
Yeah, so it shouldn't be the 6. So it should be a plus what?
Okay, +6.
Because that's the opposite of -6. And what we do to one side, we do to the other. And then you owe me $2, but you have 6. So how much do you have back? 4, right? Because -2 plus 6 is 4. And then that goes away, which is Y. So do you see why it's +4, sir?
Yes, sir.
Okay, good. Thank you for your question. Now, as for Z, guys, what'd you get for B?
I got -12. I mean, this is for B, I'm sorry. I got
Yeah,
negative
for B.
10.
-10?
Yes.
All right, good. If you got -10, Z equals -10, guys, you are correct. Good job. Right? Because how do we get the Z by itself, class? How do we move a +8 over? What's the opposite?
Negative.
And if you owe the bank 2, you spend 8 more, so you're going to owe them 10 in total. But remember, we can flip it if we wanted to. All right, for C, when you combine all your like terms, what's the answer?
-12.
-12. If you got X equals -12, good job, class. Because -2 plus 90, we combine those two, that gives you a +88. But we still have to have the -100, right? We spend $100. So we have 88, which it wasn't enough to cover it all, which gives us -12. Great questions, class. Great questions. Any other last minute questions before we move on? All right, let's move on. 18, multiplication property of equality. I'm gonna go ahead and give you guys 3 minutes to copy out the property and example 5, okay? And then I'll begin working it out. Sorry, I hear the leaf blower. I have a landscaping company doing my lawn. I can hear it in my room, that's why. Plugging my charger. So I'm gonna start reading. We have a minute left in the timer, so I'm gonna read the property, what it's saying, okay? Multiplication property of equality. Let A, B, and C represent numbers and C cannot equal 0. Then A equals B and A times C equals B times C are equivalent equations, just as A over C equals B over C are equivalent equations to A and B. So what that is saying is the other property was what we add to one side, we add to the other. What we subtract to one side, we subtract to the other. This property is telling us the other operation, that if we multiply something to the one side, we have to multiply to the other. Same thing as what? Dividing. If we divide on one side, we have to divide on the other. Okay, that's what this property is saying. And this property is going to make us have shortcuts, right? So look at the example 5. Negative 5x equals 15. Solve it. Our goal is to get x by itself. So remember what I said earlier in another lesson, that when we have a number next to a letter next to each other, they're being what? They're being multiplied. And remember, to manipulate equations, class, we need to do the opposite. So what is the opposite of multiplication, class? Anyone can tell me? Division. We're gonna divide. So go ahead and draw a fraction line, divide. We'll and divide a negative 5 in the bottom. What we do to one side, we're gonna do to the other. Now, remember the other one, we canceled them out because it was 0. Well, here, negative 5 divided by negative 5 makes a 1. So make a big 1 right here. And now x is by itself now. Well, it's actually 1x, right? But 1x is just x by itself. Right? We don't need to draw the 1. And now 15 divided by negative 5. Plug that into your calculator. What is 15 divided by negative 5? When you plug it in, look at my board and see if you got the same thing. You should have gotten x equals negative 3. We do the opposite, right? Let's try some other examples before you try one on your own. So here's example 6 and 7. I'm gonna give you guys a minute to copy down the first one before we get in. Negative 27 equals 3y. Go ahead and write it down. Now, for me, remember, I don't really like the letters on the right side, so I'm gonna flip this one. I'm gonna get 3y equals negative 27, right? Same thing. So guys, what's happening with the 3 and the y? They're being what?
Divided.
Right now they're not being divided, they're being multiplied, but we are gonna what? Divide. You're correct. Is that what you meant, right? You're trying to say what's the next step?
Yeah.
Okay, no, yeah, you're good. I figured you meant that. That's why I interjected. Yeah, you're right. We are gonna divide. Good, correct. Remember what we do to one side, we did to the other. 3 divided by 3 is 1, so draw a line through the 3's. Right, because we're dividing by 3, right? Because we had 3y. All I did is flipped it. Now I'm dividing by 3 because I want to get y by itself. Negative 27 divided by 3 is negative 9, and we're done. Look at example 7. I'm going to read it, okay? negative 12x equals negative 36. Can someone tells me what are we gonna do to move 12? Like how do we get x by itself, class?
Divide negative 12.
Yeah, divide by negative 12. What we do to one side, we're gonna do to the other. Now, the reason why we're dividing, because whenever we have a number next to a letter, they're being multiplied. So negative 12x is the same thing as negative 12 times x, right? And the opposite of times is division. So I just wanted to remind you of that fact, because I'm pretty sure I put it in your notes already in one of your other slides. And class, I highly recommend you read over your notes. Like the way I do it is like a story, and it just adds more information to the story as we do more lessons. So please look over your notes. If you're gonna remember it from just seeing me do it once, and that's it. You have to see me do it, write it yourself, practice yourself, read it yourself, watch it again if you have to. Utilize anything you gotta do to make it click. All right, so the 12s are gonna cancel out, right? Give us a 1. We get x by itself. Can someone tells me what happens when we have a negative and a negative? Two negatives make a what?
Positive.
Good. How many 12s go into 36?
3.
3.
And we're done. So far y'all have seen the dividing on both sides, right? Because we're multiplying. Check out example 8. Ooh. Ooh, it's a fraction. Oh no, drop the class. No, I'm just kidding. Don't drop my class. It was a joke. So I'm gonna give you a moment to set it up. Example 8, guys, the last one. X over 3 equals negative 2. So when a number is next to the letter, they're multiplying, right? When the number is in the bottom of a fraction, it's what operation? Is the x adding the 3? Is x subtracting the 3? Is x dividing 3? What operation is happening right here that we see?
It's dividing,
It's dividing. And what is the opposite of division, class?
multiplication.
Multiplication.
We're gonna multiply. So I want you to put a multiplication symbol, the dot, 3. And what we do to one side, we're gonna do to the other. Notice the dot is for multiplication. And then we're the parentheses for the right side. They mean the same thing. So these 3s are gonna become 1, right? We can draw a line through the 3s, bring down the x. And can someone tell me negative 2 times 3 is what? It's negative 6. And we're done. So does everyone see why we multiply 3 in this example instead of divide? Does everyone see why?
I do have a question.
Yes, Kayla.
If you multiply the 3 by the x, wouldn't that be 3x equals negative 6?
But remember what's on the bottom, Kayla.
Oh, 3.
So you are right. You are right. So when we do this, when we do 3 times x over 3, that is actually 3x on top. But what's still in the bottom?
3.
And what happens when we have a 3 on top and the bottom?
It cancels out.
There you go. Do you see that, ma'am?
Yes, thank you.
No, thank you for your question. And someone in the chat said me, please go back. Yes, Josh, I will. Let me just let everyone copy this one down. Is this the slide you needed, Joshua? Or more back? Let me know when you got the picture, Joshua. Okay, thank you, thank you. Awesome, awesome. Anytime, sir. No, thank you. And then example 8, would anyone need more time to get down example 8 down? Anyone need more time? Okay, excellent, excellent. All right, everyone, here is your practice problems. So this is your first one, number 1. number 2, number 3, and number 4. Don't forget, me and your embedded tutor, Daryl, are online for questions throughout these. I'm gonna give you 5 minutes on these problems. 5 minutes, 1 minute for each one, a minute and 15 seconds for each one. Good luck. More than enough time for you to do each one as long as you're actually working on it. How y'all feeling about these practice problems, guys? Does it feel pretty doable with the properties we just did? About a minute and a half left. All right, for the first practice problem class, 3y equals negative 18. What did y'all get for y equals? What was the solution? Y equals what?
+9. I
I heard
mean,
y equals
-9.
positive, -9. How did you get that?
Because
What did you do? How did we get y by itself?
3 divided by -18.
And how many threes go into 18? Double check your math. Count by threes.
Oh, okay. My bad.
Three. No. Don't apologize. I just don't. You're good. It's about just making sure you catch yourself, right? So 3, 6, 9, 12, 15, 18. So y equals what?
-6.
Excellent catch. Okay, good, good, good. You're comfortable with why it's -6 and not -9? Okay, what about B or number 2, guys? What'd y'all get for x equals? What was the solution for number 2?
I got +4. X equals +4.
Okay, we have x equals +4. Anyone disagree or agree with that? Look at the chat. I'm seeing x equals -4 in the chat. What
I
do we
meant
divide?
-4.
-4. Okay, good, good, good. So if you got -4, guys, if you got -6, you're correct. If you got -4, you are correct. Okay, good, good, good. Let's look at 3. How do we get y by itself for 3, right? What was y equals? What was your solution for 3? Y equals what? Type it in the chat. Y equals 9. If you got y equals 9 for 3, you are correct, class. Now for number 4, 4 is the trickiest one. Excellent. X equals -28. Now, is there any of these practice problems that anyone would like me to work out, class? Would anyone like me to work out any? I already did the first one, but what about the other one? Okay, let's look at number 2. So how do we get number 2? How do we get x by itself?
You multiply.
Are you sure?
I'm sorry, divide.
Yes, there you go. Sorry about that. I didn't specify. So we divide by 8, right? So 8's cancel out. X is by itself. -32/8 is -4. On number 3, what do we do to get y by itself?
Divide.
Divide again. Thank you. And 2 negatives make a +9, right? Last one. What do we do to get the last one?
Multiply
By what?
by 4.
Excellent. And then what we do to one side, we do to the other. And make sure we multiply, but not just a 4, but by -4, right? So the numbers can cancel out. Get x equals -28. And we're done. And we're done with 2.6, class. Y'all should be able to do homework 4 now by yourself. Now, are there any questions so far regarding 2.6?
I so I kind of just came in swimming with everybody else, but how do we get access to the homework?
So I sent out a couple emails with the instructions on Canvas. So it'll tell you to go, it'll tell you it's a PDF, it's an attachment. Just look at the Canvas emails from me. You'll see that it's like an attach. Click on the paperclip where it shows the file, and it tells you the steps, step by step, on how to get access to the homework.
Okay.
And then if you have a hard time with that, send me a message. And on Wednesday before class, if you can get on a little sooner, I'll help you do it, you know, or email me,
Yeah.
not on Wednesday, but we can actually do it like Tuesday, if you need help tomorrow, just let me know.
All right. Appreciate you.
Okay. Okay. Great question. Any other questions so far? All right. If there's no questions, go ahead and set up your notebook for test 1 review. This is the last lesson of today. So once we do this test 1 review, we would be done with today's class. I will email y'all the Word document, but we're just gonna write the problems into our notebook. Now, after we finish this review, listen up, guys. This is an important announcement. So we've gone over the first 4 sections of elementary algebra, right? We've done 1.7, 1.8, 2.5, and 2.6. Those 4 sections is gonna cover test 1. Okay, so this is what's gonna happen. We have all the notes done for the first 4 sections. You should have all the first 4 homeworks done with the 70 or higher. Once you have all of that and you have this review done, which we're going to do together as a class, you're going to do test 1 on your own. Now, typically, most professors will actually have you take the test in class. But we are adults and this is a college class. So I'm going to let you guys work on your test 1 on your own time at home. Now, the best time to do it is give yourself 2 hours. So if you have a partner, if you have a family, if you have people that rely on you for certain things, for those 2 hours, just have them be independent. Tell them, hey, I'm gonna be on this test 1 when I start it. Don't come into my room. Don't knock on my door. Don't text me. Don't tell me you need it. Have someone watch your kids. Have someone watch your dog. Just so for 2 hours, you're gonna commit to the test. Now, will it take you 2 hours? No, it won't. But that's what I would give yourself. Okay. I'll add more time, and it's also I'm giving y'all 3 attempts for each test. So if you take the test 1 and you got a 62 because you rushed it and you were doing it before work, you can do it a second and third time to improve your grade, and I would accept the highest grade. So let's say you do it the first time, you got a 62, the second time an 89, the third time a 70. I will take the 89. Is that understood? Now you don't have to use all 3 if you do not want to use all 3, okay? And if you did my review, you did the homework, you were here for the notes, you should be good to go, okay? Let's get started. So on your notebook, make sure you have test 1 review, and here is the first set of problems. At this time, this is a review, so have we gone over this? Yes. There's nothing new in this review you're about to see. So should y'all be able to do numbers 1 through 4 right now without me? Yes. Will I go over it with you? Yes. So please, please follow along and write with what we're writing. So write the instructions, write using exponential notation, write number 1, and write 8 times 8 times 8 times 8 4 times, and then write equals. And what is it equal to? What is 8 times 8 times 8 times 8 in exponential notation?
Eight cubed.
8 cubed. Does everyone agree with 8 cubed? Tanya has a 4 up. Be careful. Cube means what? What's the power for cube? Cube means what number? 3. How many 8s are there? How many 8s are there?
There's 4.
You see the 4, so it should be 8 to the power of 4. You see that?
Yeah.
Okay, there
Okay.
you go. There you go. There you go. As long as you catch yourself, right? This is a review. This is where we can make mistakes. Okay, guys? I appreciate him for speaking up, saying that he thought it was 8 cube, but now I was able to say, hey, not really, because cube means 3, where we see 4 8s. You see what I mean? So now at this time, he should, oh, okay. Now he won't make that mistake on his own doing the homework because he just encountered it with me, Look at number 2, class. 3 times 3 times 3. How would you rewrite number 2?
3 cubed.
3 cube. Beautiful word of terminology. So 3 cube or 3 to the power of 3, right? So there's more than one way to say it as.
I have
So
a
I'm not.
question.
Go ahead.
So on the first one, number 1, like how do we say 8? Is it what 8 cube? What 8 4 cube? Or how do you?
How do you say it? So the way we say it is 8 to the 4th power.
Oh, so you can't say cube for that one.
No, ma'am.
Only
Nope.
for 3.
There you go. Cube is a special word for 3. Just so if cube is for 3, who can tell me what squared is for what number? Yeah, squared is 2. There you go. So the only ones that have special terms is the power 3 and the power 2, okay? So the way you would say that is 3 to the 3rd power.
Okay.
3 to the 3rd power or 3 cube. There's 2 ways to say it, okay? Or 3 cube. What about number 3, class? Anyone want to share with me what they got for 3?
That
Excellent,
would be
Joshua.
10
Go
to
ahead.
the 5th power.
10 to the 5th power money. That is correct, sir. Excellent, excellent. What about number 4, class?
5 squared times 4 to the 6th power.
Excellent again. Bunch of nerds in this class. Nah, no, I'm not kidding. Being called a nerd is a compliment in college class. Remember in high school, you didn't want to be called a nerd? Well, now you do. All right. Are there any questions on numbers 1 through 4? Feel free to take a picture of your slide if you're still writing or need more time. But how does everyone feel about the first 4 of the review? Pretty good, right? That means you're learning. If you're able to do this on your own from looking back in your notes a little bit back, you're good. You're progressing. You ready for the next set? I'll go ahead and give you a moment to write them down. Evaluate. Can someone tell me mathematically what it means to evaluate something? At the end of it, what do we want at the end?
Don't you write it as the sentence, right? You write it as like the equation.
Ah, you're talking about words, right? This one's not the words one. This one just wants you to find a value. So if you look at the word evaluate, it has the word value in it, and a value is just a number.
It's refreshing my brain. Yeah, I appreciate it. Yeah.
No, you're good. Yeah.
No, you're good. Yeah.
So when you see 9 squared is the same thing as what? 9 times 9 times 9, right? But what's 9 times 9?
81.
81. And we're done. Everyone see now what evaluate means and that we get a number at the end of it. Number 6, 4 to the 5th powers. How many 4s are we going to be multiplying, class?
5.
Yep, 4 times 4 times 4 times 4 times 4. Remember, you're not a calculator, so plug that into your calculator.
1024.
Like this, 1024, like that.
Yes.
Can someone else double check? Just make sure. Not that I don't believe you, but it's always good to use each other as a network. Tanya, we got it? Okay, good. Excellent, class. Everyone with me so far? Let's look at number 7. 5 times 3 squared. That's just 5 times how many 3s, class? 2, right? So now we multiply. 3 times 3 is just 9, right? So it's 5 times 9, which is just what?
45.
45. And we're done. Any questions for these 3?
On the third one, on the 7, you can just do 5 times 3 times 3, right?
Yes, you can. Yes, you can.
Okay.
I only did the 3 squared first because I just follow PEMDAS, but it's not a big deal. Yeah, you can do 5 times 3, then times 3 again. We'll get the same thing. All right. You guys are doing really good. Hearing you guys, do you feel the confidence in your answers now as we move forward with this review? Because I'm hearing it in your voice and it's making me smile. Like it's making me happy to know that you guys, it's clicking for some of you guys. Now, you don't have to be perfect, okay? Like, remember what I said the first class, that I'm not expecting you to become geniuses at the end of the semester, but I'm hoping you become more comfortable and more confident in yourselves, okay? We're all capable of doing whatever we want to do as long as we put in the effort and the work, okay? Nothing in life comes easy. All right, let's move on. Simplify the expression.
I'm gonna drop the class. No, I'm just kidding.
Well, I got you recorded.
Another joke.
I'm just kidding. Thank you. So number 8. So that's an expression, right? So it'll be 2 times 4 minus 3 divided by 3. Can someone tell me what are we gonna use to simplify this? What's the steps called?
PEMDAS.
PEMDAS, correct. So look at number 8. So I wrote PEMDAS. I shouldn't write it like that. I wanted to write like this. Hold on. Like a checklist, right? So P, there's no parentheses, so we're done with P. There's no exponent, so we're done. Do we see multiplication division? Yeah, we go from which way to which way? From left to what? Right. 2 times 4 is 8 minus 3 divided by 3 is 1. Right? That gives us 1. This gives us 8. 8 take away 1 is what? 7. And we're done. Because we did that first and then that first. Number 9. Since we have a lot going on in number 9, what do we do first for parentheses? The parentheses or the brackets?
Parentheses.
Correct. What's 10 divided by 2, class? It's 5. So we're still doing the brackets, right? So in the bracket, what's next? We can't subtract yet, so what do we do first in the brackets?
Exponent.
Yeah, exponent. 3 squared is 9. Can someone tell me what 9 take away 5 is?
4.
Good. Bring down everything else. So now we're done with parentheses. P is done. Exponents, 4 cubed. 4 times 4 times 4. That is 64. Bring down everything else. So we're done with exponents. Now we multiply, divide from left to right. I'm going to highlight each step that we did. So here we did this one, then we did this one, and then we did this one. Now we're going to do this step now, 7 times 3, which is what?
21.
Good. Bring down everything else. So we're done with multiplying, dividing. Now we add and subtract from which way to which way?
Left to right.
64 plus 4 is,
68.
bring down to 21, which gives us what?
47.
47.
Excellent, class, and we're done. Any questions on any of my steps, class? Any questions at all? All right. I'm gonna go ahead and give you a moment to write these down. So for 10, we're gonna evaluate the algebraic expression for the given values, which means we're gonna plug in, right? Plug them in. So on number 10, evaluate x minus 2 if x is 7. So what does that mean for 10? What are we gonna do? Anyone want to share with the class what we'll be doing for number 10? I know you're writing it, but anyone feel confident enough to share?
Plug in 7.
Yeah, for x, right? What do we get? 7 minus what? 2, which is 5. That was great. For number 11, anyone want to share what we do for 11?
You plug in
Yeah, what do we get? What do we plug in for what? And what do we get when we plug it in?
for Y is gonna be 4. And for X is gonna be 8.
Good, like this. And now we simplify, right? We do parentheses first. 8 minus 3 is 5. 4 times 5 is equal to what? 20. Thank you, Joshua. All right, number 12. Determine whether 2 is a solution of the equation. Does anyone tell me what we do for 12? How do we figure out 12?
Plug in a 2 for Y.
There you go. So it'd be 2 parentheses 2 plus 1 equals 3, right? With a question mark on top, right? 'Cause we don't know, right? 2 times 2 is 4 plus 1. 4 plus 1 is 5 equals 3. Is that true or false?
False.
So 2 is not a solution. Is not a solution. You guys are doing great so far. Any questions on 10, 11, or 12 class? Would anyone like extra time to finish writing this down?
I need extra time.
Yes, let me know when you're good to go, sir.
Okay, thank you.
On the test, are we gonna have to write like 2 is not a solution? We're gonna have to write that sentence.
Not in this first test, but later on in the other test, you may see that, yes. So for the first test one, it'll either be like a yes or no, like a multiple choice, and then it'll tell you. But that's because that was a great question. I want to kind of follow up on that question. So the question was, are we gonna have to type out that sentence on the test online? Now you may see this in the later exam, but remember that this course, the way I have created it is to kind of give you all the foundation that you need. So you may not write it a lot in this class, but in your next math course, they're gonna expect you to write your final answers like that. It's like full sentences and stuff like that. So we're learning that technique now to avoid you having to learn that and the harder stuff. You know what I mean? So I'm trying to build y'all skill set. All right, Sarah's done. Does anyone else still writing, guys? Sarah just told me she's done. Anyone else? All right, 13. So on 13, negative 5 squared. So that's just going to be 5 squared is 25. We gotta do PEMDAS, right? PEMDAS. No parentheses here. So 5 squared is 25, but there's a negative there. So it'll be negative 25 plus a negative is just -7, right? Minus 1 cube is 1 times 1 times 1. Let me expand it, right? Let me expand this for you guys so you know what I'm talking about. So this is just -5 times 5 minus 7 minus 1 times 1 times 1. So -5 times 5 is just -25. We're now -7. 1 times 1 times 1 is just 1. So now we did the exponents done. There's no parentheses. There's no multiplication or division. So we're going to add and subtract from left to right. So -25 minus 7 is -32. Bring down the -1. Those two is just -33. And we're done. Do not overthink these expressions a lot, class. Do not. And remember, this is a review that if you're noticing why I'm going quicker on the problems here, it's because it's a review. It's not new. It's not a newer topic. Newer topics, I tend to be more lenient, slower, give you time, ask for, for questions. But here, this is a review, which is stuff we have already covered. So there's nothing new you're seeing in these examples, okay? It's all been covered in the notes. Anyone need more time to write down number 13? Or any questions so far? "14. Solve the equation and check your solution." Okay, how did I get 32? Let me go back to the problem. So -25 minus 7. So -25, Brianna, is that I owe 25 to the bank because it's negative. -7 minus 7 means I spent 7 more at the store when I owe the bank 25. So if I spend another 7 with the 25 that I owe, I now owe 32. So -32. Does that make sense, Brianna? So it's like if you had your phone, type in -25 minus 7, you'll get -32. Then I brought down the -1, which gives me -33. You're welcome. Thank you for your question. Number 14, solve the equation, check your solution. So we do have the x plus 6, right? So I'm going to bring that down. But 1 take away 3, guys, that gives me -2. I'm going to combine those two. Now our job is to get x by itself. So can someone tell me what's the opposite of +6 to get x by itself? Anyone?
Subtract 6.
Yep, we're going to subtract 6. What we do to one side, we do to the other. Cancels out. -2 take away 6 is -8. And we're done. All right. Number 15, simplify each expression by combining like terms. So I'll give you about 2 minutes to set this up into your notebook. So look at 8y and 4y. Class, is 8y and 4y like terms? Can I combine those two?
Yes.
What do we get when we combine them? 8y and 4y gives us
12. Why?
12y, correct. B, y minus 6y. So there's an invisible what in front of the y?
1.
1. And then 1 take away 6, you're still going to owe me negative 5y. Now in C, which one's the only ones we can combine in C class? Or can we combine all three? No, we can only combine the like terms. We can only combine these two. Negative 4x squared minus 6. So 4 take away 6 is negative 2x squared. And then bring down the minus 3 and we're done. Any questions here on combining like terms, guys? Any questions?
I do have a different question.
Go for it.
For number B, would it have been different and a different answer if it was 6y minus y?
Yes, it would have. So 6y minus y. So this is still an invisible one. So 6. Is this 6 positive or negative?
Positive,
But and then this 1 is what?
negative,
So if we have positive 6, but we get rid of 1, we have how much?
positive 5.
Positive 5. But here we only had how much? Positive 1 with a negative what?
Negative 6.
Great. That was a good question. And does that explain it okay though?
Yes, thank you.
Okay. Just making sure. All right. Any questions, guys? All right. Now our equation, we're gonna solve equations, but it's gonna be a little more complicated because it's gonna want us to combine like terms before. Okay, so I'm gonna give you a moment to write this down. I'm gonna give you a minute. So on number 16 class, so the first things first, draw the line on the equal sign, right? The left side's by itself 10, so we can just bring that down. But on the right side, the m's, we can do what to these m's? What's the phrasing called?
Combine like terms.
We can combine the like terms. So 2m take away 4m is negative 2m. And we have the equals 10 and move that down. So now remember what's happening with the negative 2m, they're being multiplied, right? Because they're next to each other. The opposite of multiplication is division. We're going to divide both sides by negative 2. So then we get negative 5 equals m. But I don't like this order, so I'm going to flip it over. And we're done. Excellent, Joshua. We got the same thing, sir. Good job. Any questions on how we did this example? Or problem, really, not an example. Example or notes. All right. use the distributive property to multiply and simplify if possible. Go ahead and give you guys 2 minutes to set this up into your notebook. Now remember guys, this lecture is being recorded, so you will be able to access this in the future to rewatch and do again or practice again, or to just listen to it again to just make sure you get that comfortable with the steps and stuff. So we're gonna use arrows to denote distribution, guys. So draw your arrows after the 6, right? Go into all the things inside. 6 times x is 6x. 6 times 5 is a positive 30. Quick question, class. Are these like terms? Can I combine them or am I done?
You cannot combine them.
We cannot combine them, so we're done. 18. -5 parentheses 4a plus 3. Excuse me, we're distributing the -5. -5 times 4a is -20a. -5 times 3 is -15. These are not like terms, so we are done. 19. 19 is a little beautiful because it actually has, how many times are we going to distribute in number 19? Twice, right? Do -7 here to these terms, and then the 5 here to these terms. -7 times x, y'all, is -7x. -7 times -1 is +7. 5 times 2x is a positive 10x. 5 times 3 is a positive 15. All right, class, do we have any like terms here? Can I combine -7x with something else here?
Yes, 10x,
Yep, that's correct. And then I could combine what else together?
7 and 15.
Correct. So -7x plus 10x is positive 3x. 7 plus 15 is 22. And we're done. What questions do we have on distributive property? Any questions at all?
I have a question.
Yes.
How do you know when you can combine them together?
Great question. So we can combine them. So the way I'd like to think of combining like terms is kind of like fruit. Like you can only count apples with apples, oranges with oranges, right? So if you look at the expression here, Brianna, look at the 4 terms. We have 7x, 7, 10x, and 15. Well, only 2 of them. What's the one thing they have in common? The yellow highlighting, Brianna. They both have what letter?
X.
Yeah, they both have an X. So consider those like apples. So -7x is you owe me 7 apples because it's negative. Positive 10 means how many apples do you have?
10.
10, but you owe me how many?
7.
So if you have 10 fingers up and you give me the 7 that you owe me, you have how many left?
3.
3. But instead of apples, we use what letter?
X.
There you go. Good job. And then we look at the orange, right? 7 and 15. They're both just what? What do they have in common? I'm sorry, guys. Hold on. Hold on. I'm sorry, guys. So 7 and 15 are both just numbers, right?
Mhm.
There's no letters, so we can combine them. 7 plus 15 is
22.
there you go.
I have a question.
Go ahead, Sarah.
So I know we had went over today lesson the 2.6, right?
Mm-hmm.
And then but this stuff, is it from chapter 3? Because
I don't
I don't know if we went over like this. Yeah.
did we go over distribution, guys? Let me see. I have lecture 1 right here.
I don't think so. I don't remember it either.
Yeah, because I feel like some of these questions like we didn't learn yet.
Okay, I see. So this is lecture 1, distribution. Because I know test 1, lecture 2. Lecture 2 was all equations, right? Yeah, the distribution does seem a little new to me. A little bit. I'll take a look again, okay? But once again, it's just a simple multiplication, but I'll double check and I'll make an announcement once I look at my notes, okay?
Okay, thank you.
All right. Actually, yeah, we'll stop here because I want to actually look into that real quick first. Because we have a couple, we're down to the last 2 questions actually. 1, 2, 3, 4, 5, 6. We have 6 questions to go, but this looks. Yeah, we'll go ahead and stop here and then we'll finish this review on Wednesday. I'm gonna look over the notes. You're right, because looks a little, we haven't done over this, right? Yeah, I feel like maybe I dropped the ball and I missed a couple sections. All right, let me go ahead and yeah, I'm gonna stop the recording here.